There are areas on the Earth, near large mountains, that are very dry or desert-like. These dry areas are called rain shadow areas. What causes a rain shadow? When wind flows up a mountain, the air is moving into an area that has lower air pressure, making the rising air expand and cool. When air cools, its capacity to hold moisture in the form of water vapor decreases. Water vapor is the gaseous form of water. As air continues to rise up the mountain, it cools to the point it's at its maximum capacity to hold water vapor. When air is at its maximum capacity, it is at 100% relative humidity. Further cooling will cause excess water vapor to condense or turn into liquid water. This forms clouds. If enough condensation occurs, rain or snow will fall out of the clouds. As long as the air continues to rise up the mountain, condensation, clouds, and possibly rain or snow will occur. The side of the mountain where wind is flowing up the mountain is called the windward side. Many areas of the world experience large amounts of rain or snow where air is forced up mountains. The western parts of Oregon and Washington states are good examples of this process. As air flows down the other side, or the lee side of the mountain, it starts to warm. The warming is caused by the air getting squeezed together as it moves downward into higher air pressure. Warmer air can hold more water vapor, so condensation does not occur when air is sinking. If there is no condensation, there are no clouds, and therefore no rainfall. Dry or desert conditions prevail on the lee side and are known as the rain shadow area.
The rain shadow effect on the Big Island of Hawaii. Rain shadows are dry areas on the back sides of mountains. The downwind side of a mountain, the mountain creates a shadow of dryness. We've got that here on the Big Island. It's the most famous place to study this effect. You can go wet side to dry side of this island in a 60-mile drive and go from Hilo side, which is more than 120 inches of annual precipitation, that's more than 10 feet, by the way, of rain per year, up and over the Saddle Road to the Kona side of the island, which has less than 10 inches of rain a year. That's quite a transition. What is going on here? Here in the Pacific Northwest, we've got the same effect. Western Washington is famous for its rain, but there's a strikingly different landscape on the other side of the Cascades. Washington's the evergreen state, but half of it's everbrown. Okay, you want a rain shadow effect? You need 3 essential items: an ocean nearby, winds blowing steadily onshore, and a mountain range to block the traveling air mass. Here's how it works. Evaporation on the surface of the ocean creates moist air. Prevailing winds push the wet air inland until it hits the base of the mountains. The air is forced to rise, and as the air lifts, it expands and cools. Cooler air can't hold as much moisture, so clouds form, and it rains a bunch, resulting in a lush green landscape. The now dry air mass crosses the mountains and begins to sink on the leeward side of the range. It compresses and warms, promoting evaporation. Dry air warms 1 degree Celsius per 100 meters of elevation drop. Some of the driest places around the world exist because of the rain shadow effect. There's a rain shadow north of the Himalayas in Asia, a rain shadow west of the Great Dividing Range in Australia, a rain shadow east of the Sierra Nevada mountain range in California, and that rain shadow southwest of Mauna Kea on the Big Island of Hawaii. And here in the Pacific Northwest, we actually have 2 rain shadows.